Okay, hello. From last week and from the previous lecture, we learned about concepts in GIS, such as buffering and layers, and you know, we said that these methods actually allow us to do a whole lot of interesting things that can be applied in civil engineering. For example, if we wanted to know which building should come down, then we do a line buffer which creates a polygonal area. Are you okay? So the buffer zone then can kind of tells us is it as an area constrained around the object of interest. Okay, and then we also talked about layers being very important, how data is collected at different themes, with different themes. For example, we could be collecting data on rivers and collecting data on temperature. These two are two different ideas, two different themes. Okay, so in GIS we kind of do that, and then we separate data, and then we can now overlay them again. So we have layers, and these layers can be overlaid. Are you okay? All right. So now what we want to talk about today is that having looked at the concepts of GIS, what can we do with the data? How can we actually get data? Who should go and get the root center lines for us to be overlaying? Someone has got to do that job, and that data acquisition process, okay, leads us to the data sources. So primary data sources are the ones that we are looking at. Okay, we are assuming that the existing data are the secondary data sources, and I know some literature try to talk about primary and secondary, but I don't think that's necessary. Are you okay? The most important thing is that we really appreciate the data we need, so that if it's already even prepared, we will know how we got it, how it was prepared. And of course, we can look at metadata. We have already looked at metadata, and so we can appreciate existing data sets. Are you okay? So surveying is one of the most important data sources in GIS, because basically we just measure from objects on the ground. Are you okay? We measure distances to them, angles to them, we compute distances. Are you okay? Surveying is a technique in science of accurately determining the terrestrial or three-dimensional position of objects and the distances and angles between them. Okay, these points are usually on the surface of the earth. Of course, where else could it be? And the coordinates that's obtained are often used to draw plans or maps showing boundaries for ownership for governmental purposes. But obviously, we can also look at engineering surveying, are you right, where the surveyor is really on the ground on a construction project. But here, you can see that surveying is looking at it beyond the building. Are you okay? That space. Are you okay? Surrounding the building. We are looking at beyond that. Are you alright? So we can actually use surveying to actually draw up plans and maps showing boundaries and etc. What surveyors do is that they are able to also collect other attributes. If you like, they supply questionnaires whilst they are surveying to find out who owns the property. Are you alright? Okay. So basically, we may not even be interested in all that. What we're really interested in is the location, the position of things, in which the surveying instruments allow us to measure coordinates. Are you okay? All right. So obviously, talking about property boundaries, then we touch on LIS, which is land information systems. So geographical information systems. Excuse me, and land information systems. All right, so surveying really allows us to measure just the length, the angle. We can also look at the elevation and all that. If we need to have the elevation, we can also measure it using the survey equipment. We can measure area and volume from, of course, the coordinates. All right, and then etc. We can do what we call the horizontal and vertical control survey. At the end of the day, the coordinates are controlling the work that we are doing. Are you okay? So that is where we come by the control survey. Area photogrammetry. Here we make use of photographs. So we fly over an area, and when we fly over the area, we take what we call vertical photographs. Okay, which in other words, we can have tilted photographs, which we may need to correct before or or transform before we can actually, use. Are you okay? Now, if you don't have vertical photographs, which are truly, planimetric, so the word planimetric means that they are really like, you know, they are actually a mapping of objects on the ground onto a horizontal surface. Are you okay? So they are like the plan. Are you right? What you obtain in the plan is actually an orthogonal projection of everything on the ground. Are you okay? I don't know if what I'm sounding a bit too deep, but I need to for civil engineering students. But obviously, it's a photogrammetry allows us to create a model, a 2D or a 3D model. Are you okay? Well, what do we mean? The coordinates define the ground. So area photogrammetry is a technique for creating two-dimensional or three-dimensional models from aerial photographs, which are really pictures of the earth. Pictures of the earth. Okay, so moving forward, then we can say that we need to actually have some kind of sensor mounted on the platform. When we talk about the platform, we're really talking about an airplane. It could be a helicopter or anything at all. It could be the drone that people are using around to take pictures at weddings. Are you okay? But it needs to be stable enough to take the pictures. Well, what kind of pictures does it take? It takes overlapping, or if you like, non-overlapping photographs. Any of them will work. Depends on what you're looking for. If you're looking for a 3D model, then you need to do the overlapping photograph. Is okay because the overlap area is where the model is actually from. The 3D model is from. Otherwise, if you have a 2D, then in that case, if you need a 2D model, you don't need to have overlapping photographs. Are you okay? Now, any the product from or the results from area photogrammetry are auto photographs. One of the most popular products is auto photographs, and these photos are corrected of the error due to tilt and relief. Relief is really like we're talking about areas that are rising up and going down. Yeah, you okay? All right. So features on the earth that actually kind of change in height and elevation, they are called relief. And so now, when you have a photograph with relief, there are all sort of errors are introduced. Are you okay? Into the final, product that you have in your hand. Are you okay? So now you need to correct for tilt and really the tilt of the camera or the sensor. Are you okay? Most of the time, the sensors are cameras, but of course, the actual film or sensitive material, is actually may be sensitive to a particular frequency. Are you alright? Now, for most of these AR photographs, of course, they are actually sensing from the visible region of the electromagnetic spectrum. We'll talk about that. Light, are you okay? Light actually belong. Everybody here in this class know the basic physics. Are you okay? That every camera is sensing light. Are you okay? But then you can have an infrared camera too. That is why we want to differentiate between these things. All right. So now take note of that. During aerial photography, you realize that ground controls are needed. We need to establish them on the ground and mark them prior to a flight. It's very important. This allows us to actually, you know, create the model in such a way that it can relate. We can relate to it on the ground, not some kind of fictitious, theoretical model that we cannot work with or combine with existing data sets. So ground controls are needed. Not too many of them. Are you alright? But then we need a few to control the whole photogrammetric process. Are you alright? Now, one of the products that you also get from area photographs is the digital elevation data. Are you okay? This can be acquired from stereo photogrammetry, and stereo means two. So we're talking about the overlapping photographs. They are also known as a stereo pair. So stereo photogrammetry can help us to obtain digital elevation, which can be a great source of information to GIS. We get to know that. Are you okay? So here we are getting the actual model, which is made up of, coordinates. Are you right? Right. So a model, a continuous model, which we can actually measure from. Are you okay? And we can also obtain the photo itself. So they are almost like two sets of data. We are getting all three. Are you okay? The auto photographs, which are corrected. Are you okay? It can be used like a normal map. planimetric map. All right, so that is it for you know what you call area photography. All right, so like you said, we can use them the pictures themselves, the photographs themselves as a background. Are you okay for an overlay? So we're doing some work, some drainage work. We want to see whether the drainage are actually where they're supposed to be. We can overlay them on an area photograph, which has actually been georeferenced. We will talk about this. An area photograph in which the coordinates can be associated with, in other words. Um, and so we can actually digitize from the area photographs too. All right, so let's take note of that. Another method for data collection or data acquisition will be the global positioning systems. Are you okay? So global positioning systems are GPSs. Now everybody has GPS in their phone, so it's okay to talk about it. All right, they are navigational and precise positioning tool, a navigation and a precise positioning tool. In other words, GPSs were designed to help you find a place, to get to a place. Are you alright? So let's assume that someone gave you a coordinate, all right, in longitude and latitude. And I can't be teaching longitude and latitude here, but when someone gives you a pair of numbers like that, then how do you really find a place? You can use a GPS to find a place because the GPS actually tells you the coordinate where you are. So you can virtually work out how far east or how far north, west, south that you are to the point that you are looking for. Are you okay? So assuming you actually wrote a program to take care of this, then you'll be navigating yourself to the place. So the whole software will be telling, or the software will be telling you that you are too far south or you are too far north or east or west. Are you okay? So that's navigation right there. Are you okay? All right. So when you get lost in the forest, you could always use a global positioning system to find your way back home if you knew where you started from and the coordinates at that point. Okay. So that's global positioning systems for you. That's global positioning systems. Okay. So carrying on, you can see that the global positioning systems are really designed. Originally, they were designed to help soldiers to actually, of course, for defense. Are you okay? So the U.S. Department of Defense, they actually started this whole thing. Other countries have actually joined in. So what the United States call GPS, other countries call it by with different names. So you can have the GLONASS project, you can have the Galileo, you can have the Compass, you have that for China, and then you can have the RNSS for India, and in other words, you see the way it works. Anybody can create their own GPS. I'm not sure about Ghana, but yes, anybody can create their own GPS. Let's carry on a little bit more about global positioning systems. Satellite is actually this is how it works. You have satellites launching into the sky. The satellites are trying to now, your receivers are talking to the satellites. So your phone is talking to the satellites in the sky, and then the satellite is actually transmitting its position, and your phone is trying to now compute its location relative to the Earth. Simple as that. Are you okay? But basically, you have about 24 satellites moving in about six orbits. So what is an orbit? An orbit is like a path, okay, around an object. Are you okay? So we are orbiting means you are going in a circular path. So it's a circular path. So now you can see that the receivers on the ground are trying to talk to the satellite in the sky. Are you okay? Now you can have the handheld GPS, or you can have the one that you actually mount on a tripod. Are you okay? So either you're holding your hand or you're mounting it. Are you okay? All right. So basically, that is it. You have a satellite constellation that your receivers are talking to. So here you can see a typical receiver, and then etc. Now this is an animation which is not playing because this is a PDF originally. It's supposed to be a PowerPoint. Sorry guys, but I hope you actually can see it. I can show this to you sometime. You can see that all the red dots and the black dots are actually indicating like satellite positions, and the satellites are not actually stationary. They seem to be moving. So at any particular point, the satellite that's available to you is the one that you use. So you can actually have a poor, configuration of satellite to compute a position. Are you okay? So the precision for calculating your position can change, and that's why sometimes when you try to use GPS on your phone, it seems not to be too accurate at a point. But what are some of the uses of GPS? They can be used for commercial and scientific purposes. They can be used to study the weather. They can be used, for Uber is using GPS. Are you okay? Yango and all these taxi, car, the car rental or whatever services, are you okay? Car services. Most of them are actually transportation services are actually making use of GPS. It can be used in planes. Are you okay? To determine where we are when we fly the plane. Sometimes a map is shown, telling you where the plane is at any particular point in time. GPS is being used in the planes. It can be used in boats, it can be used in cars. We all have heard of the good uses of GPS. And there's an interesting story of two people who went kayaking and with holiday. They were actually climbing mountains and all. White folks like doing that a lot. Okay, not black people. But whilst out there, they got lost, and then they found a note there that said that we couldn't find our way, and they were wondering who wrote this note. And then they walked a bit further and found, some bare bones, implying that those people who wrote the notes were dead. Are you okay? In other words, they couldn't find their way out. So finding where you are is very important, and finding fish also can be very important for the fish farmer, isn't it? Or what do they call those people? The fishermen, isn't it? So for hiking, finding your place, for doing a whole lot of things, GPS will do a good job. But right away, GPS data will feed into GIS for interesting analysis. Okay, that's the whole idea. So take note of that. It's a very accurate method for surveying, and it's being used in the surveying and mapping division in Ghana and in most survey and mapping organizations in a lot of countries for mapping. Okay? So in other words, it can be used. Okay, for in a whole lot of work. Are you alright? So the precision can be to the centimeter. Of course, that is why. All right. The smaller the better. Are you okay? If you can get to sub millimeter, of course, millimeter level of accuracy. Why not for engineering work? Okay, so then earthquake studies, we can use GPS to do that. Depending on the method actually used, it can get very accurate. So GPS, we have what we call the differential GPS and all that. There are different methods, but we are not going into all that. How does GPS actually work? There's what we call there are three segments of it: the user segment, the control segment, the space segment. Are you okay? So these are the three segments. The user segment is where the use is made up or comprised of the users. So airplanes, you and I, how we use GPS in our phones. A control segment controls the satellites in the sky. Then we have the space segment, actually the satellite out there. Are you okay? All right. So like I said, you can have a minimum of 24 satellites with 4 satellites in each orbit. Are you okay? So 6 orbits with 4 satellites each. Then you can now have these orbits about 11,000 nautical miles above the Earth. So you can see that it's really, really far, high up there, about 20,000 kilometers. Really, that's not too far anyway compared to from here to the sun. Yeah, so that is how GPS works, global positioning systems. Are you okay? They are very, very accurate, all right? And like I said, it can be used. Are you okay? The output of GPS is just a set of coordinates, okay? Now, if you want to appreciate the different segments, there you go.